What is radar? How does it work? And would it be useful for integration into a product like Hawkeye? Well, radar stands for radio detection and ranging. Radio detection and ranging. Radar, it's an acronym. And radar goes back to World War II when the British were defending themselves against the attacks from the Nazis. When the planes would fly over the channel, they needed to know when and where they were coming. They were really outnumbered and defending their homeland, and they had the Royal Air Force going up to try and find these planes and attack them. The Germans were always surprised. It didn't seem to matter where they went and how they approached across the channel. The RAF was always there. And they weren't aware that the radar was the reason they were always vectored on. Fabulous story of how this all came about just in time, along with the wonderful Spitfire aircraft, to really repel what was a relentless attack. And this really changed the tides of the war, World War II. What they did was they set up a bunch of radio towers all across the coast areas, and they would coordinate the information back to a central office along with an observer corps, which would try to estimate heights and a whole lot of other information to try and coordinate the best place to put the defending fighters. Well, that's another story. I just find it fascinating myself. How does radar actually work? Well, it just sends out a pulse of radio, and then it listens for the echo. Now, because it's the speed of light, it can go a long way, effectively across the English Channel, bounce off an aircraft and come all the way back. Now, let's take that down to what that means in our world and where we might see radar that's useful. Of course, it's used in airports, it's used in marine. Now it's finding its way into cars. Cars are using radar for collision avoidance, mounting a radar on the front of the car. If something is in front of you, the radar can see it, and it can even apply the brakes to ensure you don't run into something. I think it's a wonderful feature. I think many times I have been shocked as to how close it has come when I'm distracted, and I'd love to have a system that does that. These can be quite sophisticated systems that have means of detecting the angle and go out to quite a long distance. If we come down another level to something even simpler, there's a product called the Garmin Varia Radar, which has been out for, I believe, since 2014, and it uses a slightly lower frequency than the automotive, which is around 76 gigahertz. This is operating at 24 gigahertz. These are specific bands that are allowed to be used for radar, because radar is quite high power as you send out these beams of radio waves, but it is a dedicated channel for radar to radar systems. Why the lower frequency? I believe that's because it actually requires less power at those lower frequencies than it does at the higher frequencies. Now, in a car environment, you've got a big engine and an electrical system. In a bike, you don't really have a battery. Now, the Garmin is known to run to sort of 3 to 5 hours with this radar running off the battery, and so I would calculate that's about 300 milliamps. The antenna, unfortunately, is a little bit bigger in this 24 gigahertz realm than it would be in the 77 or 76 gigahertz. So that's a trade-off they chose to make. I don't think it makes the product too large, but when we consider integrating that into Hawkeye along with the cameras, it's a significant consideration. Would 76 gigahertz be better, smaller antenna, or do we have the power consumption lower with the larger antenna array? When I say large, we're talking about the two antennas being roughly this high from top to bottom. There's two arrays. I believe there's a transmit array and a receiving an array coupled into a chip, dedicated RF radio chip, and then it goes off to the digital circuits and the power circuits and so forth. There's a couple of iterations. I've got some pictures here which we can show you of the older and the newer version. The new one's more refined. There's two boards bonded together. And how would we integrate this into Hawkeye? So I think we could take the RF antenna stage and maybe some digital circuits, rebuild a 24 gigahertz system, and then mechanically fit that in. What that physically would look like could be challenging as we consider how to fit the antenna facing backwards, as well as the cameras, as well as the responsive light. It certainly could be done. What are the trade-offs? Okay, so more power is going to be drawn. The advantages is that the radar will give some information about distances, perhaps better than in some cases, especially at night or where there's a occluded environment like fog or smoke. So it could do a better job of actually supplementing the information. But then you've got these two systems running together. And what happens when the camera sees something and the radar doesn't, or vice versa? Are we generating more false positives? Now, this was one of the key concerns that users had with the Garmin Varia system, is it just keeps generating these false positives. So there's quite a bit of work that needs to be done in the integration of these two technologies to make an improved user experience, one where they're getting reliable information and not getting false positives or false negatives. So the other thing is, of course, cost, size, other things go up. But maybe there's an application directly in the e-bike space where power consumption is less of a concern. We can draw off the main battery. Therefore, we don't need to worry too much about having lots of batteries in the device itself. So maybe this kind of thing is better suited to e-bikes. There's a fair bit of work to do it. I think we would have to bring on engineers, and there would be certainly some costs and development to be done. And there's no certainty that this would absolutely improve the user experience, which is what we're ultimately aiming to do. Thanks for watching.